All right, you guys, we're going to do the lesson here for 8.4. We're going to be looking at translations of a linear equation. So let's see. First, we got Fernando Maria training for 6 weeks to run a marathon. To train, they run laps around a track. And since their schedules do not allow them to run together, they run each and keep a record of the total number of laps they run throughout the week. And then they always train together on Saturday morning. The following are representations of how each person kept track of the total number of laps that they ran throughout the week plus the number they ran on Saturday. Okay, let's see. So Fernando's time on Saturday, so 0 to 10, 20, 30, 40, 50 minutes. And this is the number of laps he ran in that amount of time. Oh, it looks like, I see, looks like he ran for 50 minutes and then he was keeping track of the number of laps as he went around. What observations can be made about the similarities and differences between the two trainers? Oh, and then here's Maria. Here's her time. Oh, she also ran for 50 minutes. And there's her distance in laps. Oh, I see. This is Saturday. So they've already run during the week. So I see. So Fernando already ran 60 laps during the week. Okay. Fernando ran 60 laps during the week. And then on Saturday, they ran together for 50 minutes. I don't know. Where Mariah ran 40 laps. 40 laps during. Okay, so that's that. Between the two trainers. And then I think what we're looking at then is on Saturday, like who ran faster, basically, I think. So in 50 minutes, Fernando ran. You guys see this here? Um, what is that? Fernando ran 30 laps, 91 and 60. Ninety minus 60 equals 30 laps in 50 minutes, which is what? Let me get the right one. Which is 30 in 50 minutes, which is 3 laps in 5 minutes. Or 3/5 of a lap per minute. Mariah. So that would be his slope, right? If we drew that line, that's what that slope would be. 3/5 of a lap per minute. And Mariah, M-A-R-I-H, ran. So she goes from 40 to 70. Oh, okay, because they're running together. Also, because she's going 70, right? 70 minus 30, so this is still 30, right? 70 minus 40 is still 30 laps. Write the equation. that models Mariah's distance. Oh, that's easy. We have an initial value of 40. So we're going to go y equals 3 over 5 t. Oh, mt. So we want a function. Function mt. There we go. Plus 40. There you go. Well, Fernando, just for the fun of it, Fernando would have been the same thing, right? 3 over 5 t plus 60. Okay, cool. Next one. Fernando both said they ran the same rate during the week when they were running separately. Explain in words how Fernando's equation is similar to Mariah's. Use the sentence frame. The rate of both runners is the same throughout the week. However, Fernando. Oh, okay. Okay, so we'll say the rate for both runners is the same throughout the week. However, Fernando. How can Fernando cover more distance if he's running the same rate? Right? He ran 60 miles, she ran 40 miles. Even though they're both saying they're running the same speed, the same rate, well, that means that Fernando must have run for more time. There's no way that make that happen if they have the same rate. Translation form versus slope-intercept form. Sometimes one function can be used to build another. Write Mariah's equation mt by starting with Fernando's equation. Okay. So again, if we draw Fernando's equation, he started at 60, had the same rate, ended up at 90 at the end, right? So basically, the question is this: this is a vertical translation; it got moved up. And so to go from 40 to 60, this is a plus 20. And same thing over here, right? To go from 70 to 90, we had to add 20. That's why it's parallel, because you're adding the same amount on both sides. So basically, we just have to add 20 to Fernando's equation. So we're going to say, all right, we're going to say that this is like the translation form. So by starting with Fernando's equation, right? So if we go mt equals Fernando's equation, right? Mariah's equation by starting with Fernando's equation. Well, I guess that's actually a minus 20. It's actually a minus 20, isn't it? They're telling us to start with Fernando's equation and come down. So they're actually telling us to come down. Start with Fernando's equation and get Mariah's equation. Okay. Okay, so we're going to drop 20. Fine. So that will be Fernando's equation. And we will drop 20. So that's the, that'll be the translation form. All right, next we're going to do the slope-intercept form. All right, okay, so mt equals, all right, so we already know Fernando, we said this last time, he was 3 over 5t, and we're going to go, what was he, plus 60? And we're going to subtract 20, which gives us m of t equals 3 over 5t plus 40. Yeah, it's exactly what we had before. Okay, there you go. Okay, next one. Use the graph to draw the new graph translated up 3 units. Oh, this is so easy, you guys. So all we're gonna do is add 3 to each one of these things. So it's gonna be up 3. It's gonna go like to here. We're gonna go to here. Go up 3 here. Go up 3 here. Go up 3 here. Up 3 here. And up 3 here. And we'll connect them. Let's change it to 3. There you go. Easy enough. There you go. Something like that. Number 5, draw the new graph translated down 1 unit. Also, so simple. Can't believe that everyone's do this. What is weird about this, though, is I think it's too big. Let's see. Is that some of these start to get kind of like not exactly. Oh, yeah, look at that. They start getting. Yeah, you just have to estimate, right? Down 1. Right on the line, slightly over. On the line. There. Mm-hmm. Look at that. 2 inside the same box. And this last one right below. So there you go, easy enough. Last one here. Oh, we've been given equations, transformation. Oh yeah, so you can do the plus k. We did that a second ago. Graph them both. Okay, so here's f of x, translation form. So we're gonna take f. We're gonna drop it by 8. Yeah. So that's pretty simple, right? So this is gonna be going down 8. We're gonna drop it 8. So 1, 2. Right. We're gonna y-intercept was 6, right? And now it's going to be 1, 2, 3, 4, 5, 6, 7, 8. It's going to land right there. Y-intercept is going to be it's going to be 2 when we're all done. Let's drop this down to 2. 1, 2, 3, 4. I'll put it down here. 2, 3, 4, 5, 6, 7, 8. Aha. So the graph will look something like, something like that. Oh yeah, they should be parallel because they'll have the same slope. We're all done. X plus 6, right? Transformation form. So what do we get if I go x plus 6 minus 8? It becomes x minus 2, and that makes sense, doesn't it? Because what is the y-intercept over here? Y-intercept over here is negative 2, right? So yeah, x plus 6 minus 8 2. Okay, last one. This is the last one. Yeah. Okay. Based on 1/2 minus 1. Oh, here they are. See, it's parallel because it has the same slope. Um, we know it's going to be negative 1/2 x, right? So g of x translation form. So the translation form is you take f of x. I suppose you could write the whole other thing. Um, and it's being dropped, right? How much is it going down? It's being dropped. Let's see. We're going to go 1, 2, 3, 4, 5. It's coming down 5, right? So it's coming down 5. So if I take away 5 from this, what do I get? I get negative 1/2 x minus 1 minus 5, which is minus 6. Which, yeah, okay, duh. It is. It's minus 6 because there it is. It's negative 6 for the y-intercept. That's what we get to. Okay, slick. All right, you guys. So, oh yeah, so there's a problem set 8.4 due Tuesday. These dates are wrong. I gotta change those. Uh, I'll update them in Canvas. Don't do that. The 1.3 I think was due yesterday, and then 8.4 will make this too popular on Wednesday. Okay. All right, guys, take care.